Alright, so I just got finished showing us how to name this function using the sine function, but now we're going to work on part 2, which is writing an equation for the cosine function. So parts of this are going to remain unchanged, but parts of it are not going to be the same. So if we look at the equation I wrote, my amplitude, whether or not it's sine or cosine, really shouldn't change at all. The b term, which helps determine the period, also should be changing because the period did not change. The third thing that never changes is the midline, because the midline is the exact same graph. So a thing to keep in mind is that the m, a, and p values, midline, amplitude, and period values, are never going to change. So that means my a, b, and m values are also not going to change. Things that may change, positive or negative, depending upon sine or cosine. Obviously, sine and cosine could change. And then what's missing here would be an h value. A shift, a horizontal shift could change. So whether it's positive or negative can change, whether it's sine or cosine can change, and the h value can change. So let's look at that if we were going to now choose cosine instead of sine. So I just said that some of the things aren't going to change, and so some of those, again, to reiterate, M, A, and P don't change at all. My midline is y equals -2. My amplitude is 3, which means the maximum was 1, and the minimum was -5. And the period was 2 pi over 3, which means that the b value equals 3. Instead of writing this as a sine function, I'm now going to write it as a cosine function. So if we write in what I already know, I know it's going to be y equals, I haven't determined if it's positive or negative yet, but I know that it'll be 3 times the cosine, I know it's 3 because that's the a value, cosine of something. And then also, what I can tell is, if this is a cosine graph, where does cosine begin? Cosine begins either at the maximum if it's positive, or at the minimum if it's negative. But if I look at the y-axis, there is not a positive or a negative on the y-axis. So that tells me there is actually going to be a shift here. So I know that it'll be something, and then plus or minus something else. For the h, I'm going to leave space for it. And then the last thing I know will be minus 2. So to go back, since I already know that the b value is 3, I know this is going to be 3 times x, and then it'll be plus or minus some other amount, whatever the shift is. So what I need to figure out now is to go back and simply find a point near the y-axis. I'm going to go ahead and choose this maximum point here. If this maximum point indicates that we're within a positive cosine, so I don't need to worry about the negative. And now the only thing left to do in my equation is figure out what was this shift. Well, ideally this point should be on the y-axis at the maximum point of 1, but it's not. It was moved to the left by a value of pi over 6. So if I'm moving left by pi over 6, a move to the left is what type of horizontal shift? That's actually an addition, right? Because h is horsing around, and so it goes opposite of what we'd expect it to do. So this means that it's going to be plus the amount of my shift, which is pi over 6. Again, I get that from the scale. So I just put in pi over 6, and now I have my second equation using the cosine function instead. So I can say y equals 3 times the cosine of parentheses 3 times parentheses x plus pi over 6, close them up, minus 2. Now if we compare these two equations, again, notice my a term is the same, my b term is the same, and my m term is the same. However, the cosine function also has an h term horizontal shift. They're opposite functions, sine and cosine, and then the sine function was negative, but the cosine function was not, the way that we wrote it. Here again are the two different equations that are talking about the exact same graph, but just using two different functions, sine function and cosine function. Thanks for watching.